Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. So today we will present our program-based learning project of signal and system. So in this project, generally divided into two sections, which is project 1 and project 2 in a group of 5 members. So let's begin. So our group consists of 5 members, which is Muhammad Syamil Hatim bin Sofyan, Muhammad Amirul Daniel, Danesh, anak lelaki Ajinta Kumar, Muhammad Syamrin Syamil bin Muhammad Saidi, and the last one is Muhammad Ashraf bin Ismail. So our objective that we have identified has three focus, which is first to enhance our proficiency in MATLAB, explore advanced functionalities, and apply mathematical and computational technique to address real-world challenges. Second, to foster a deeper understanding of algorithmic design, data analysis, and visualization within the MATLAB environment. And lastly, to design our own audio of wave sound.
Assalamualaikum, a very good day. So today I will explain on the introduction on this project. So MATLAB is a potent tool in the realm of science and engineering. Facilitates efficient problem solving for researchers, scientists, and engineers. So this project serves as a comprehensive guide catering to both novice and experienced users. It helps to navigate the vast application of MATLAB and boasting an intuitive and expressive programming language. So MATLAB is a streamlined development process allowing users to focus on problem solving rather than programming intricacies. So the exploration extends to MATLAB ecosystem of toolboxes and each designed for specific application spanning signal processing, image analysis, control system, machine learning, and also robotic.
So I will present about question number one. In the question number one, ask to copy the script and paste in the MATLAB. So basically, the command is used to demonstrate basic operation with complex numbers, including addition, multiplication, absolutely value, angles, and logarithm. The results are stored in variable for further analysis or display. So as you can see, the output will show like the figure that we have attached in this slide. In the question number 2, the following script shows the conversion from one form to another of a complex number. The function cut to pole is used to transform a complex number in rectangular or from Cartesian form into polar form, and as expected, the function pole to cut does the opposite. So, this code takes a complex number of m obtained by adding two other complex number, which is z and v. It then converts m from rectangular coordinate to polar coordinate, and it will display the magnitude of phase of m. And finally, convert the polar coordinate back to rectangular coordinate. The actual result will depend on the value of z and v used in the computation. In the question number 3, the following script illustrates the graphing capability of MATLAB. It will show graphically the generation of a sinusoid from a phasor. So this code appears to create an interactive plot showing a rotating complex vector in one subplot and a sequence of red points in another subplot. So we need to key in the input of frequency, amplitude, and phase, and the visualization evolve over time with pause to observe the change. The hold on and hold off commands are used to retain the current plot while adding new elements.
Okay, hello. Next, I will explain about uh, part 2, question 1. Okay, first, but clear all comment. This comment clears all variables from the workspace. It's often used at the beginning of a script to ensure a clean workspace. Okay, next is load train. This command loads the variable name train from a file named train.mat into the workspace. Okay, and next is whos. This command displays information about the variables in the workspace, including their names, size, and data type. So when run these codes, it clears all existing variables, loads the train variable from a file, and then display information about the loaded variable using the whos command. Next, I will talk about question 2, part 1. Okay, sound YFS. This command replaces the audio signal represented by the variable Y with a sampling frequency of Fs. It uses the default audio player of MATLAB. Okay. Next is T equal to 0, 1 over Fs. Length Y minus 1 over Fs. This line creates a time vector T representing the time instant corresponding to each sample in the signal Y. The time vector is generated from 0 to the duration of the signal with a step of 1 over Fs. Okay, figure 2. This command creates a new figure with the figure number 2. If figure 2 already exists, it makes in it the current figure. Plot T y prime. This line plots the signal y against the time vector t. The transpose operation y prime is used to ensure that y is treated as a column vector. Okay, command grid. This command adds a grid to the plot. As you can see at the picture, this has been a grid. Yeah, a grid. Okay, y label y n, x label n. This command label the y axis as yn and the x axis as n. So when you run this code, it plays the audio signal like you can hear about train signal. It plays the audio signal and then plot the signal against time. So this plot will help visualize the waveform of the audio signal. Okay. Okay. Next question 3. This MATLAB code snippet use the stem function to plot 200 sample of the train signal. Okay. Figure 3, this command creates a new figure with the figure number 3. If figure 3 already exists, it makes it the current figure. Okay. N equal to 100, 299. This line defines the range of indices samples to be plotted. It selects sample 100 to 299 from the Y signal. Okay, stem and Y 100 uh, 299. The stem function is used to create a stem plot. It plots the values of y against the indices n for the selected range of sample. Okay, x label n and y label yn. This command label the x-axis as n and the y-axis as yn. Title segment of train signal. This sets the title of the plot to segment of train signal. Okay. Next is axis 100, 299 minus 0.5, 0.5. This command sets the axis limit to display only the specified range in the x-axis and restrict the y-axis between negative 0.5 and 0.5. Okay. So when this code is run, it will create a stem plot showing a segment of 200 sample from the train signal, providing a more detailed view of the signal within the specified range. As you can see at the picture, the plot is the signal is plot.
A very good day. My name is Danesh and I like Ajinta Kumar. Today I am going to present about the project of signal system. My part is case 1. First of all, from the code, from the coding clear to the save as.mat file, showing that import into mat file and save as.mat. And second, we have to load the mat file, which is in the coding that shows that load in bracket and showing my name. After that, we have to use one column of data, which is shows in step 8, which is y equals to y in bracket double dot comma 1 and until the one column. After that, we have to identify the sampling frequency fs, which is shown in step 9, which is written as percentage already obtained from audio read. After that, we have to calculate the time factor, which is called t, also shown in the coding step 10, which is L length y, t 1 over fs, and for alphabet of t is 0 double dot L minus 1 times with t. After that, we have to plot the original signal, which is shown in step 11 in that coding, which is the first figure, plot in bracket ty, and the title is origin sound signal, and for the x label time second, and for the y label is amplitude. After that, we have to plot the first 100 second, which is the second figure, also that call plot in bracket t open bracket 1 double dot fs times 100 close bracket comma y open bracket 1 double dot fs times 100 close bracket, which is shown in that coding. And the title of this plot is first 100 seconds of sound signal, and for the x label we call time second, and for the y label we call amplitude. After that, we have to insert zero mean random noise, which is shown in step 13 in that coding, known as noise plus signal equals to y plus random in bracket size t close bracket. After that, we have to plot the signal with noise first 100 second, which is the third signal, which is also called as third figure. It is called like plot in bracket t open bracket 1 double dot fs times 100 close bracket comma noise plus signal open bracket 1 double dot fs times 100 close bracket, which is shown in the coding. The title of this signal is first 100 seconds of sound signal plus noise. For the x label we call time second, and for the y label as usual we call amplitude. After that, we have to play sounds and comment, which is shown in step 15, which is sound in bracket y comma fs close bracket semicolon percentage original sound. After that, pause length y over fs semicolon percentage wait for sound to finish, and then sound in bracket noise plus signal comma fx percentage sound with noise. After that, pause in bracket length another bracket noise plus signal 1 over fs close bracket semicolon percentage wait for sound to finish. This all coding is included in the coding. After that, we have to do the fast Fourier transform FFT and plot frequency domain, which is shown in step 16 and 17. Y equals to FFT y, n equals to length y, f equals to in bracket 0 double dot n minus 1 close bracket times open bracket fs divided by 9 close bracket semicolon. After that, figure semicolon plot f abs y. Title we call frequency domain minus original sound signal, and for the x label we call frequency in bracket hertz, and for the y label we call amplitude. After that, y noise we call FFT in bracket noise signal 1. This figure we plot as a first one is f value and abs y noise, and the title we call frequency domain minus sound signal plus noise, and for the x label we call frequency hertz, and for the y label we call amplitude. And that's all for the coding explanation. After all this coding input, we have to click save button and the run button to show the three figures as I mentioned before. Thank you.
Hi, my name is Muhammad Syamil Syamil and I'm going to explain the case 2 of the second project, which is noisy signal analysis by FFT instruction. Okay, first of all, we need to specify the parameter of signal with sampling frequency of 1 kHz and add the signal duration to 1.5 seconds. Include the value of sampling frequency, sampling period, length of the signal, and the time vector. After that, we need to form a sinusoid signal containing a 50 Hz of amplitude 2 and a 60 Hz cosine wave signal of amplitude 4. Then we need to corrupt the signal with zero mean white noise with a variance of 4. And last but not least, plot both of the original signal and noisy signal in the time domain. Okay, for the next step, here I will show you how to create the plot of single-sided amplitude spectrum of x of t. First, we need to compute the Fourier transform of the signal, which is y equal to FFT of x. Then compute the two-sided spectrum P2. After that, we also need to compute a single-sided spectrum P1 based on P2 and the event value signal of length. Lastly, define the frequency domain F and plot the single-sided amplitude spectrum. So the last step of my part, which is to plot a single-sided amplitude spectrum of S of t. We just need to take the Fourier transform of the original signal and retrieve the exact amplitudes. That's all from me. Thank you.
Summary, MATLAB proves to be an indispensable tool for researchers, scientists, and also engineers, offering an intuitive programming language and a rich ecosystem of toolbox. Its efficiency in solving complex problems across diverse applications makes it an invaluable asset, empowering users to innovate and address real-world challenges with precision and ease.